So children, to begin with, Standard 10th, Chapter number 5, Coordinate Geometry. First, we know what is geometry, children. It is the branch of maths concerned with the properties and relations of points, lines, surfaces and different shapes, solids and higher dimensional analogues. It is used, we know, in mapping essential elements in professions such as surveying, navigation and astronomy. So, but what is coordinate geometry? We know it is that branch of geometry which is used in study of points in relation with coordinates to uniquely determine the position of points on a manifold such as Euclidean space. We always talk about Cartesian coordinate system. We know there are different coordinate systems. Which are they which we have studied of? A few to name is number, line, Cartesian coordinate, polar coordinate system, cylindrical or spherical coordinate system, homogeneous coordinate system and so on. But today we will deal with the Cartesian plane, that is the coordinate system. We know the coordinate system consists of two axes. One, as you can see, is the x-axis, which is a horizontal line, and the other one is a vertical line. They're always drawn perpendicular to each other. The intersection point of these two axes is always with the numerical value 0. The x coordinate, we know these are x coordinates. The numerical values of any point on x line, that is the x axis, is always called as the abscissa. The numerical values of any point on the vertical axis, that is the y-axis, is always called as the ordinate. So, the x coordinates, we know, children, is always called as the abscissa, and the y coordinate is always called as the ordinate. Both together sum up as coordinates of the points lying either on x-axis or y-axis. We saw when we draw both the axes perpendicular to each other, they divide the whole plane into 4 quadrants, 4 sections, and as we go anti-clockwise, they are named as the first quadrant, the second quadrant, the third and the fourth quadrant. So each numerical value on the x-axis is called as the abscissa, and any numerical value of any point plotted on the y-axis, which is perpendicular to the x-axis, is always named as ordinates. Together they are called as coordinates. So children, as I have already told you, the different coordinate systems, the first one which I said was the number line. We have always seen, children, now that we know that any x coordinate is called as abscissa and any y coordinate is called as ordinate, or together to write down the numerical values of the position of any point lying either on the x-axis or on the y-axis or in any quadrants are called as coordinates. So, to begin with, how do you find out the distance between any two points? We know that any point given to us with its positioned value given to us, the numerical value given to us, we find out the distance between any two points. Between points is always given by the formula, that is greater numerical value minus the smaller numerical value. In other words, greater coordinate minus the smaller coordinate. Now, to look into detail, if I take a point A where it is positioned on the x-axis, at the point 5, and as we already know, any point lying on the x-axis, its y-coordinate is always 0. And you take any other point B, whose coordinates are 2, and as the point is lying on the x-axis, its y-coordinate is 0. And if it's asked, find the distance between AB, find length AB, how do we proceed with? So children, the coordinates of A are 5, 0. The coordinates of B are 2, 0. To find distance AB, how do we proceed? If you look into this problem in more detail, we see that the y-coordinates both are 0 because the point is lying on the x-axis. So what do we do? How do we imply this formula? That is greater coordinate minus the smaller coordinate. So where do we concentrate on? We concentrate on only the x-coordinates. 5 and 2. Which is greater? 5 is greater. So greater coordinate minus the smaller coordinate. That is equal to 3 units. So thus the distance between AB, or you can say length AB, is equal to 3 units. Let's take another example, children. Here I take two other points. Point C where the coordinates to be precise with will be 1, and as it is lying on the y-axis, on the x-axis, the x-coordinate is 1, y-coordinate is 0. Another point D, whose coordinates will be -3, that is the x-coordinate, and again the y-coordinate is 0 as point D is lying on the x-axis. To find the distance between CD or length CD. Again children, now we know on the number line we have seen to recall with. At the center you have 0, towards your right you have all positive values. And as you proceed, we have seen the next successive number is greater than the preceding value. But what happens when you proceed towards your left of 0? You have your negative values, and each preceding value, the one comes before the other one. So each preceding value is always greater than the successive values as you move towards your left of your origin. That is 0. So over here, -1 is greater than -2. -2 is greater than -3. -3 will be greater than -4. -4 will be greater than -5. Or in other words, when you compare negative values, the one which is towards your origin, that is the preceding value, is always greater than the next successive values as you proceed. One more thing that you should always remember, every positive value is always greater than any negative value that you take. So children, to again come back to our problem, let's first write down the coordinates of C and D. So what is C? The coordinate of C is 1, 0. The coordinate of D is minus 3, 0. So, again over here, we see as both the points are lying on the x-axis, y coordinates are 0. So, we just concentrate and look into the x coordinates and use this formula to find the distance. So, distance CD will be equal to greater coordinate minus the smaller coordinate. Which is greater now? Over here you have 1 and the x coordinate of D is minus 3, and just now we saw that every positive value is always greater than any negative value. So which is greater, children, over here? 1 is greater. So greater minus, the formula goes with the difference of two coordinates. So minus of the smaller coordinate. The smaller coordinate also has a negative value. So we should not forget the negative sign. You know, the operation of multiplication is taken when you open the bracket. So 1 minus into minus gives me plus, which is equal to 4 units. So distance CD is equal to 4 units, or length CD is equal to 4 units. Let's take one more example, children. Now over here, let's take the same point D and take another point in succession towards the left. Let's take it D, and this is point E. So what are the coordinates over here? For point E, it will be minus 7 and y coordinate will be 0 as it is lying on the x-axis. So let's find distance ED. Again, first let's write down the coordinates of E, that is minus 7, 0, and coordinate of D, that is minus 3, 0. Distance ED again, using the same value formula, that is, in other words, finding the absolute value gives us the distance between any two points. So now, E, over here y coordinate is 0, so let's concentrate only on the x coordinates. E over here has x coordinate as minus 7, D has x coordinate as minus 3. So which is greater? Is minus 7 greater or is minus 3 greater? As we have seen, unlike the positive values which go successively greater towards your right of your origin, you have in the negative side, what happens? Minus 1 is always greater than minus 2. Minus 2 is always greater than minus 3. As you proceed, that means every preceding value is greater than every successive value when you go towards your left of the origin. So, which is greater? Minus 3 is greater than minus 7. So, greater coordinate minus the smaller coordinate. So, minus 3 bracket is always the operation of multiplication. So minus into minus gives me plus. And how do we solve this, student? Two numbers with unlike signs. Always you take the difference. And when you get the answer gets the sign of the greater number. So 7 minus 3 is 4. Who was greater? Was 3 greater or was 7 greater? Only concentrate on the numbers. 7 is greater. What is the sign for it? Plus. So the answer is plus 4 units, and we know distance is never negative. So what did we see, children, over here? We saw by taking different values or different points lying on the x-axis, how we calculate distance. The only formula that we use is greater coordinate minus smaller coordinate. In other words, children, in case you have been given 2 points, A is positioned at 4, B is positioned at 3. Find distance AB. So it will always be greater minus smaller, that is 1 unit. In case you have 2 points, C, the position value is minus 7 and D is minus 2. How do you find out distance CD? So distance CD will be greater coordinate minus smaller. Who is greater? Is minus 7 greater or minus 2 greater? Again, both are negative. So who is greater? The preceding first value which comes towards nearer to your origin, that is 0, that is minus 2. Minus 2 is greater, taking the difference with the other. So minus 2, minus into minus gives me plus. 7 minus 2 is 5 units. So over here, children, we saw different examples where the points were lying on the x-axis. Let's proceed to see how to find out the distance if the points are lying on the y-axis. So let's take few points. And see how do we calculate the distance between any 2 points when the points are lying on the y-axis. To recall with, again the formula remains the same, that is greater coordinate minus the smaller coordinate. So let's take few points, children. Here I have point A. So the coordinate of point A now. Remember, the point is lying on the y-axis. Any point lying on the y-axis, its x-coordinate will be 0 because it is positioned exactly at which coordinate? At 5. So x-coordinate is 0 and the y-coordinate is 5. Let's take one more point. Again, it is positioned on the y-axis. So its x-coordinate is 0 and y-coordinate will be 1. So how do you calculate distance AB? So it will be, as the x-coordinate is 0, let's concentrate only on the y-coordinates. So it will be greater minus smaller. Who is greater? Is 5 greater or 1 greater? Definitely 5 is greater. So greater minus smaller. That is equal to 4 units. So distance AB is equal to 4 units. Let's take one more, children. Again, point B, I'll take it as it is. Let me take another point C. It is positioned on the y-axis. So again, x-coordinate is 0 and y-coordinate is now minus 2. So let's find out distance BC. As x-coordinates are 0, let's only concentrate on the y-coordinates. Again, y-coordinate of B is 1, y-coordinate of C is minus 2. So we know every positive value, every positive numerical value is always greater than any negative numerical value. So 1 is greater than minus 2. So who is greater over here? 1. So greater minus the smaller coordinate. The smaller coordinate is minus 2. So 1, operation of multiplication. When you open the bracket, so minus into minus gives you plus. So that is equal to 3 units. So distance or length BC is equal to 3 units. Let's take one more, children, where I take the same point C, who's got coordinates 0 and minus 2, and let me take a point D, who's positioned at x-coordinate is 0, y-coordinate is minus 6. So distance CD will be, now let's concentrate on the points. Let's concentrate on their coordinates. X-coordinate 0. So where do we concentrate on? We concentrate on the y-coordinates. Y-coordinate of C is minus 2 and y-coordinate of D is minus 6. Who is greater? Again, we have seen as we move towards our left, the preceding value is always greater than the successive value in line when you move towards the left of your origin. So minus 2 is greater minus smaller coordinate. So that is minus 2. Minus into minus gives me plus. Again, two numbers with different signs. Unlike signs, always take the difference first and the answer will get the sign of the greater number. Okay. So 6 minus 2 is 4. Who was greater? Leaving the sign, 6 is greater. What is the sign before it? Plus. So the answer is again with the plus sign. So 4 units. Distance CD is equal to 4 units. So what did we see, children, over here? We saw how to find out distances between any 2 points by using only one formula, that is greater coordinate minus the smaller coordinate. Where were these points? They were either positioned on the x-axis or they were positioned on the y-axis. Now, to move on with and proceed, if the 2 points are lying anywhere in the quadrants, we know we have 4 quadrants. So, if the points are lying anywhere in the quadrants, either both the points might be lying in the first quadrant or the third quadrant, or one point might be lying in the fourth quadrant and another point in the third quadrant. How do you find out the distances between 2 points lying or being parallel to the x-axis or to the y-axis? So let's proceed. In the next session, we'll talk about finding distances of these lines parallel or distances between any 2 points which are parallel to the x-axis as well as the y-axis.